Hi, welcome to another repair video for this classic HP35670A dynamic signal analyzer. And if you haven't seen part 1 of this video, I'll link it in down below. Yes, this is part 2 in a series, maybe, depends how long it takes me to fix this thing, repairing this unit, or attempting to repair because we don't know if it's whether or not it's beyond economical repair, or whether or not it's gonna just require another 5-minute video to fix. I have no idea, but I had a lot of people comment on it. Can I do extra videos fixing this thing? And yes, that was my intention, to do videos until it's repaired, or until I decide it's just not worth the effort. So here we go. I'm gonna have another look at it, another crack at it. Now, to recap what happened last time, we have a known faulty power supply, which presumably took out, or best guess, took out a 7912 negative 12 volt regulator on the digital board, and that stopped the oscillator working. So we have got to the point where the unit does actually power up and runs through the software, so all the digital part of it's working fine. But we were getting error messages on there saying that the ADC ASIC has failed, and a lot of people said, well, let's go push the ADC ASIC back into the socket and all that sort of thing. No, I don't think that's going to be the case. Or it could be, but I think the most probable scenario of what else is wrong with this thing is, well, more power supply stuff, because we've had a known fault in the power supply and at least one failed voltage regulator. Usually they're pretty reliable, and usually the failure mode is a high voltage on the input, which could be caused by a failed mains power supply, which we know we have. These are known faults. So rather than chase our tail, chase red herrings, and follow the service manual for the rest of this thing, that whole 70-page troubleshooting guide for this thing, you got to take a step back, think about this, and go, well, what's most likely to be wrong with this thing? Is it actually the software tells us there's a fault with the ADC ASIC? But hey, if there's no power going to the ADC ASIC, then you're probably going to get exactly the same error message. So I reckon where I would put my money on is that we have more failed voltage regulators on here somewhere, because apart from the 5-volt rail on this thing, which we know is good and all of our digital logic is working, so it's unlikely that the failed switch mode power supply has taken out anything on the 5-volt rail on any of the boards. So that's the only one which is powered directly from the mains power supply. The others, this has plus minus 18 volt rails and an 8 volt rail, and I think and a 12 volt. Yeah, and a 12 volt rail as well. Now, take the plus minus 18 volt rails, for example, they aren't powering the op amps on all of these analog boards directly, because a design of a unit like this needs to have low noise on the power supply, so it's going to locally regulate those on the other cards, like this one, for example, which I've just taken out. And sure enough, ta-da, I'll show you this in closer detail, but we have some local on-card regulation. I'm not even looking at the service manual, but first port of call is to measure those regulators and see if it's failed, because if we've taken out one voltage regulator, a very good chance that we've taken out some others as well. So forget the service manual. I smell some faulty regulators. Let's go. Now, of course, the absolute first thing I do, golden rule of troubleshooting, thou shalt test voltages. So what I've done is to access all of the voltages coming out of the power supply here via this ribbon cable. I've just taken the ribbon cable out because it's not once it's on this motherboard, gone over this cable onto the motherboard, it's not real easy to probe. I can probe the 5 volts going onto here, but how do I probe the other voltages? So I just disconnected that. I have powered it up, and I have measured the voltages, and here they are. Thankfully, the service manual provides a chart telling you what pins are what. But basically, we've got the plus 18 volt supply here, measured 18.3, minus 18 volt supply, minus 19.3. It's a bit high, but it's neither here nor there, really, because this 18 volt rail, as I said, is probably not powering anything directly. It's just going into local, say, 15 volt regulator or something like that to power the local op amps. So really, 19.3, I'm not going to lose any sleep over that at all. Not worth chasing that. There's nothing doing there. Plus 12 volt rail is 12.3 volts. The plus 8 volt rail is a little bit low, 7.7 volts. But once again, that plus 8 volts is probably doing some local 5 volt regulation. So plenty of margin there, you know, 2 volt drop on a standard 7805, something like that. And we've already measured the 5 volts in the previous video, and it's just hunky-dory. So everything coming out of the main power supply here is just fine. But of course, this is the repaired power supply. So the original one likely could have, well, we think it's taken out that 7912 voltage regulator we had in the previous video. And my guess is it's probably taken out some others as well. I'd probably be surprised if it hasn't. Now here's the analog processor board here, and I haven't checked the service manual, but presumably that is the ADC ASIC that they're talking about there, the Actel FPGA there. So I believe that's what they're talking about, and you can see that we have 3 on-card voltage regulators there. And if we have a look here, we've got some test points, minus 15 volts here. So as I said, the minus 18 volts, it's just regulating that down to minus 15 volts. We have plus 15 volts here. We have minus 5 volts here. And we have, well, plus 5. We don't need to measure because it'll be coming from the same point. There's no, so we've got 3 regulators there powering those particular rails. So first thing we need to do is measure those. But unfortunately, the really annoying thing is that because this is a plug-in card, I can't just, you know, once we slide that in there, we can't access those anymore. So, but thankfully it's got these nice test posts. I'll just whack some alligator clips on there, have those coming out, just laying on top of the board. They'll be able to poke out through the side here, and we'll be able to plug those into our meters, no problem at all. Let's measure them, see if they're any good. Actually, I just realized that I missed one there. That's actually plus 5 volts A. For A stands for analog. The other plus 5 volts is here, and that would be coming, as I said, directly from the main power supply there. But this one's a plus 5 volts, and there is the tiny 78L05 to go along with that puppy. So I need another probe on there, so I'm going to be probing 4 different voltages. Alright, here we go. Let's power this sucker on. I've got the ribbon cable back in. Ground is coming from, it's going to be one common ground for all of them. Now what I've got here is plus 5 volts analog, minus 15 volts, plus 15 volts, and minus 5 volts here. So let's do, I don't know, let's do that plus 5 volts analog first. So we'll plug that in, and yeah, we're getting plus 5. So our analog, that little TO92 package, low power regulator was just fine. So our analog. Now we've got our negative 15 volts. Hello. Yep. Oops. It looks like we have a shorted pass transistor in that puppy. So it's feeding that minus 19.2 volts straight through to the output of the regulator. Classic failure mode, shorted. There you go. So, you know, it wasn't hard at all. My guess was correct, my hunch was correct. There we go, plus 15 volts, no problems at all. So that one hasn't been taken out. So we have an example of 2 negative voltage regulators being taken out on this thing. So it looks like that one rail. So I think this one here, this minus 5, no, the minus 5 should be okay, but no, hello, minus 5 is minus 1 volt. So it looks like we have now 3 failed negative voltage regulators. And of course, one other thing I'm going to be looking at here, these dip tantalum caps, these can fail quite easily in over voltage situations. So you've just got to be careful, visually check those. They can be really nasty, but you know, visually they look just fine. So I think no problems there with the tantalums, but you just got to keep that sort of thing in mind. And if we have a probe of this negative 15 volt regulator here, in and out, as I said, shorted pass transistor. So, yep, there we go, 0.3 ohms between inputs and out. And before I rush down to JCar and pick up some regulators, because I don't have any 7915s in stock here, well, let's just take a look at the main analog input board, and bingo, look, we've got some more regulators as well, minus 15 volts. These aren't the same though, these are LM337 and LM317, whereas the other ones aren't the adjustable type, they're just the fixed 7800 series, and there's a plus 5 volt one here as well. So I'll whack some probes on there, and we'll put this card back in and just measure this board here. And we've got two other TO220 packages here and here, but they're transistors, they aren't actually linear regulators. And our 5 volt rail there is just fine. And let's have a look at, this should be negative 15 volts. Aha! Negative 16.5. So there you go. Yeah, that one, I don't like the look of that at all. Well, the test point is labelled 15, so it is an LM317, of course, which means that the resistors could be out, or it could have been trimmed to that, or you know, actually set to that. But yeah, I don't like it. It should be minus 15. It's likely the regulator's gone, and plus, well, there you go, 16.5. You could argue that that's 16.5. They're suspiciously close to each other, so I'd say that's not a fault at all. I would say that's they've been deliberately set to 16.5 even though the test points are 15. That would be my guess, and it turns out my hunch there was right on the money, because if I flip the board over and have a look at the resistor values here and here which set it, they're both the same, 237 ohms and 2.87k, and you whack that into the formula for the LM317 and you get about 16.4 volts. So there you go, it's not set to 15 as it actually says on the test points there. So yeah, just got to watch out for stuff like that. That could lead you up the garden path, waste time and effort. And yes, we have got a couple of these wimpy thin tab ones. Cost-cutting bastards. And these ones actually have a solder tab on the underneath of the heatsink there, so the heatsink just, it's a slide-on type, but then secures down with a single tab. And really, the easiest way to get these out, if you know it's damaged and you don't want to use it again, just get in there and slice the pins off, and then just heat up and pull the pins out one by one. Then you don't have to worry about heating up all three at once, or doing the, you know, the sideways dance, putting sideways pressure on it and then heating up the joint. Bugger that. And then of course you just want to wick the holes out. Apply some more solder on there if you really want to, but there we go. Don't pull them, don't wipe them across or anything like that. There we go. Oh, almost. That one had a bit more solder on it than we anticipated, and bingo, 3 nice holes. And just to check that shorted pass transistor in there, here we go. Hello, 10 meg. Look at that. Holy crap, it's not the regulator. What do you know? Protection diode. Let's go to the board. There we go. We've got a crappy little, like, you know, 4148 type signal diode there going between the input and output of that. So let's measure that and see if that's the sucker that's shorted out. Oh, sorry, this doesn't show up very well on video, does it? No, input and output. There we go. We're still getting our 0.3 ohms we got before, so almost certainly that diode. Well, let's hope it is. Alright, I've lifted one end of that diode there, so let's measure that again, and I can't see what else it would be. Yeah, bingo. Look at that. No problems whatsoever. So it looks like our mains power supply, in this case, I don't know if it's taken out the regulator. It could have, so you would replace the regulator as a matter of course, you know, considering that you've already got it out, and it's, you know, $1 to whack another one in. You just put it back in. You wouldn't bother testing it. But yeah, took out that little reverse protection diode there. Little pissant thing. They put in a big 4001 or something, probably would have survived. But of course you have to wonder whether or not because you know, we were getting that negative 19 volts directly on that negative 15 volt rail, and it's been there for some time that we've had all this powered up, and presumably when it failed as well, it went through. So hopefully we haven't blown up anything on that negative 15 volt rail attached to there. It looks like the other regulators have just gone pop, you know, the pass transistor bang, and you know, and they're reasonable at actually protecting the circuitry they're powered to. But this one, because it's gone to the effort to short that output diode as well, well, yeah, hopefully not too much abuse on that minus 15 volt rail. Well, only one way to find out: replace it all and power it up. And that is a National Semiconductor. It's got 10050 on it. Not your standard 1N9144148 by the looks of it. Could be. Offhand, I don't know that part number. Okay, they've all been replaced. Let's power it up. And that's the minus 5 volts. That's working just fine and dandy. Fixed. Minus plus 15, which we had no problems with before, and minus 15, brilliant. Alright, I replaced that diode with just a 1N4148, should be good enough, whatever it was, whether it was a signal diode or a Zener diode, whatever, it's going to be good enough for to get this thing working again, and there we go. I don't know, let's plug in all the cables and power the thing up, see if we still get that error message. Booting system. Recall state. We may have to run through, like, clear the log and all that sort of stuff, but here's where it failed before with that ADC error. So let's see if it still does. Calibration in progress. Oh, hardware error, see fault log. Okay, well, yeah, calibration failure, change state, yeah, blah, blah, blah. Calibration, we'll turn that off. And system utility, more, fault log, IDC, I2C, no device, acknowledge your calibration failure. Okay, no more ADC failure, which we'll get in before, I believe. So that could have fixed that. So let's now run in, let's go into the self-test. Self-test and let's run the quick confidence test that we did last time, and we've got a whole bunch of failures. Failed! Wah. There we go. Alright, we still have ADC gate array. There we go. Looks like, I think we're still gonna, yeah, gate array failed. Bugger! Bugger! I thought that I was reasonably confident we were going to fix that by fixing our power rails, but what? Murphy gets us again. Well, the next thing I did is just take this board back out and just feel around the main chips to see if there's anything that's overheated because it's been taken out by the that minus 15 volt rail, because we don't have the schematics, don't exactly know what things on here are power, but no, there's nothing obvious. There's a whole ton of op amps here which are presumably, plus minus 15 volts a pop, and no, nothing obvious. There's a Raytheon chip there. Woohoo! You don't see Raytheon chips that often. Other thing to do is check that we're getting SCL and SDA. There's some test points on the board, and yeah, sure enough, we get something there. Let me change to another test point. Should use multi-channel, but couldn't be bothered. There we go. That's looking like it's doing something, and then we've got 10 megahertz and 20 megahertz test points for the ADC and stuff. So yeah, look at that. Whee, there we go. It's dodgy because I've got these ultra long leads coming out of here, and it's just, oh man, and the ground's going over to the digital board, and the loop in there is absolutely ridiculous. But all we're checking here is that we're actually getting a signal there, and sure enough, 20 megahertz and 10 megahertz, because sometimes you're not after the signal, you don't care about the signal integrity, and that looks like 10. Yeah, 10 megahertz. So we're getting our data there. You know, there's a few other test points on there. I'm not sure what they do. Would probably have to look up the manual and troubleshooting guide for that, but it looks like it's doing stuff. And I'm not particularly encouraged by the constant overload LEDs on the input there. That indicates something wrong. I mean, these things have dedicated overload and half rail circuitry in there. So to have, and we've got that sort of flashing down there periodically for the half rail. So they've got like dedicated, you know, op amps and dedicated comparator circuitry in there to actually detect that stuff. And well, those LEDs are coming on. You know, that's not like the processor turning those on or something like that. That's all analog stuff. So that's not good. And I'm getting nothing on the source output either. I mean, the LED's coming on for the source output. I mean, it looks like we're getting something there, but trust me, whether or not I turn that source off or on 1 volt peak sine wave or different types of output waveform, nothing. So source ain't working. Oh, well, what can I say? I tried. Yeah, there's going to probably be some more videos. Run out of time yet again. This is all I'm going to do for today, but hey, we found a couple more negative voltage regulators failed. So clearly that the original power supply failure on that negative 18 volt rail has taken out at least 3 voltage regulators, but all the other rails look fine. So we're getting the exact same ADC gate array error now. So I don't know, now I'm getting, you know, a bad feeling about that minus 15 volt rail, which went to minus 19. Shouldn't be a huge deal, but you know, that diode was shorted out, so all that power was going through there into the analog rail. So hopefully it hasn't taken out too much, but maybe we have to go back now to the troubleshooting guide, because once you check your power rails, then you'd go systematically back through to your troubleshooting guide. And that's probably what we'll do next time, and hopefully we'll find the sucker. But anyway, I was really hoping that would fix it. I was, you know, pretty confident, sort of, you know, 80% sure that fixing those regulators would do the trick, but nope, clearly not. I've tried to press that ADC ASIC back in the socket, and no, nothing. So, oh well, the saga continues. Catch you next time.